about Bazel and RBE, right? That's a wonderful job. I have no complaint so far. But yeah, I'm very biased. I think Bilbody is the best in the market, right? As a customer, you're gonna save a lot of money talking to us. So yeah, one day a customer came to us and say, "Hey son, we got a bunch of Windows CI machine lying around, and they're already using Bilbody for Linux. And is it possible to convert some of these CI machine, bare metal, right, into Bilbody RBE worker, which is our Bilbody executor, instead of running local CI for hardware optimization because bare metal is very expensive, right?" And we went to work. So yeah, Bilbody will start support Windows RBEs very soon. We are currently testing it internally, right? This is on top of our existing Linux and macOS support, and it will be released pretty soon as a standalone build. But today, I'm not going to talk about Windows support. I think Angelo folks going to have a really dedicated session about Windows sandboxing tomorrow. I'm excited for that, right? What I want to talk to you about today, which is supporting Windows on Bilbody executor in our existing code base, does come with some cost, right? It's not free. First of all, it's an additional platform. I will talk about platform a little bit later, but it's an additional to support on top of our Linux and Mac OS for the build and release matrices. Second, we have to introduce a new set of specific Windows-specific dependencies, right? And in the future, maybe more because we need to support better sandboxing for Windows as well. Third, most engineers on our team don't use Windows day to day, right? So it's really hard to test and to develop Windows-specific features. So yeah, these are some of the challenges that we are running into today. So these are CI/CD pipelines currently. They are very specific to Linux and Mac OS, right? Each of these run on separate platform, which is Linux or Mac OS, or some enable RBE, right? And if you take a really close look, these are actually graph, right? These are not really CI/CD pipeline. From a zoom out perspective, they are actually graphed. So I went to thinking, why don't I just convert them into Bazel graph, right? We just heard about Skyframe. Should be easy, right? So yeah, if we could just introduce a single node, right, convert everything else into nodes in Bazel graph, then I could just do everything in Bazel. What is so hard? So I went to do some research. I opened up Bazelarium, which is essentially our development documentation. And in our development documentation, there is a secret incantation that is not very well known because we don't use that very often. But this was written by the core member of Bilbody long times ago, right? And this bash command essentially let you run a build from a Mac laptop on Linux remote executor, Linux environment remotely, right? And this was really new to me because when I onboard onto Bilbody, I can only build the entire repo on my laptop locally. Like I could not build it remotely on Linux. So this was very new. I was like, why don't I use this every day, right? So previously, I took it out for a spin. I tried to run the command, right? Previously, from the same Mac M1 laptop using this new set of Bazel flag, I was able to build artifact for Linux, run tests against Linux environments. Better yet, I could run most complex integration tests that we have against real database, Postgres and MySQL, because we run most stuff on, we run those complicated integration tests on Firecracker micro VM, right? And these are faster too, right? Over my local Mac M1 laptop. So with RBE, I could build all the targets, test all the targets, run integration tests in Firecracker. A clean build and clean test is a lot faster compared to my local MacBook. Guess why? Because we have a lot more CPU to spare, right? Over on the RBE side, I was running with 1,500 cores compared to my M1 laptop, 10 cores. So yeah, how does this all work? What do this particular flag do to enable this magical experience that I could just use 1,500 CPU core for a single build within a few minutes, right? Is that all you're gonna need? Is it? And this led me down to a long path of reading and researching in different Bazel primitives and how they fit together. And yeah, this is the main topic of the talk today, Bazel platforms and friends. And yeah, disclaimer, not everything I'm talking about today is really built, right? Some of them have yet to be built, and hopefully we will be able to finish by the end of the year. So first of all, let's talk about platform, right? Platform is actually a set of a collection of constraint values. What is a constraint value? A little bit on that later. Execution properties specified by the users, right? These execution properties will then later map to our remote to our RBE action scheduler to schedule the action execution on the right hardware machine, on the right workers. Right, so that's what execution properties is normally for. Here you can see is matching, is telling the scheduler to match the action of this platform with a Linux machine with different isolation options. Right, we support Docker, Firecracker, Podman, etc., and container image, which is like the image that we're going to convert into a Firecracker file system, so that we could run your action on top of it. Straightforward enough. So what is constraint value? So we need to start with a constraint setting, right? And constraint setting, you can think of them as enum, right? They are used to describe the underlying properties of your execution system. For example, if you're running some stuff on different OSs, right, on a different CPU, compiler, linker, then your constraint setting will be an enum for each of these types, right? Then you have constraint value, which are the value of the previous enum, right? So for example, for a constraint setting for operating system, you can have different constraint value, Linux and Windows, CPU, x86, ARM64, etc., right? And yeah, Bazel platform is a combination of these values grouped together, right? It represents the underlying system of the execution, and it let rules author declare the requirement of the execution on top of your build file. Right? And yeah, rules and toolchains consume these value later. Click. Clicker. Hello. My clicker doesn't work because my speaker notes might be too long. Just 1 second. All right, I will use a laptop instead.
You want me to stand here and
all right, yeah. So yeah, how does platform work in practice? In the good old day of local execution, you have 2 scenarios. The first one is very straightforward, right? You have the host platform and the target platform, right? You compile a binary on Linux, and then you can run that binary on Linux. It's very typical. Later on, there would be folks who want to develop for Windows and Mac OS, but don't have the CI budget for Mac OS lying around. So we invented cross-compilation, cross-build, right? So you can use a Linux machine with the right toolchain and the right SDK dependencies to cross-compile a binary and cross-link it targeting Windows and targeting Mac OS, right? So these are cross-built. Now, with remote execution, these are a lot spicier. Now, the execution does not happen on your own machine, right? You have the wide range of flexibility to choose which kind of platform you run your action on, right? You want to run your build on. So you can basically stand from a Mac OS laptop, execute your action, your build on a Linux platform, targeting either Linux, Mac, or Windows, free of choice, right? So things get a lot spicier and more interesting. So go back to our original desired build graph. Theoretically, you can actually construct a multi-platform build graph using host to exec cross-platform, right? Because purple over here is essentially, let's say, is my Mac OS laptop. Then all these orange, blue, yellow, green, whatever is a different execution platform running remotely on a cloud server somewhere. I should be able to do that, right? Theoretically. And then later on, maybe I can introduce different interdependencies between different platforms. And a lot of these some of these are even being developed as of yesterday. I was looking into Skylib and, the platform repository, and I saw some sign of this from Bazel team. But yeah, what is stopping us from accomplishing this? Problem number one, toolchains are hard, right? I was the person who created a GitHub discussion on how we are missing default CC toolchain that is hermetic and easy to use. Right now, there's no such thing exists. Bazel toolchain is very complex, especially Java and CC toolchain in general. Moreover, these toolchains are mostly made by the preconception that host platform and execution platform are the same thing, right? But with RBE, that assumption is no longer whole. We can actually use a lot more, effort into improving this entire ecosystem in general. And yeah, many rules only register host toolchain because they relies on repository context OS to detect the current host toolchain to set up the toolchain. So yeah, if you're not familiar with toolchains, then this is a pretty good example of how it works. Ignore the gray out stuff. Only the highlight stuff is important, which is a toolchain would often have to declare itself that is execution compatible with a certain set of constraint. Those are constraint value, and then target the stuff that it produce would be compatible with different platform, right? So having these values right is very important. Aside, you can find, these help Bazel automatically select the right toolchains when you want to execute. This is a pro tips, right? If you're setting up a toolchains, copy what RulesGo is currently doing. In RulesGo, it's very flexible. You can register multiple set of toolchains, right? Each gonna generate different set of execution and target compatibility, and all these toolchains will be registered to Bazel, and Bazel will pick these toolchains automatically. And the best part, these are lazy loaded, right? So if you don't use them, they will not get downloaded, and therefore your build is still fast. So you can theoretically declare 100 set of toolchains, right, and use only one of them, and you would only have to download a single one. So yeah, register more toolchain. Please don't register your toolchains using repository context.os, because these come with the specific implication that the execution environment is the same with the host, right? Which make it really hard for remote execution to adapt. Pro tips number 2: avoid execution to target execution and target differences in cross build. The reason is that with remote execution, you can actually just set up multiple different execution machines and then produce the target there, right? So previously, you would have to cross-compile. Let's say you're targeting Windows, you're going to have to download the entire toolchain and compiler for Windows. I think Windows has a very specific CC compiler that you need to download with the entire glibc that is compatible with that, and then you cross-compile it on your Mac OS to a Windows machine, right? Now you don't need to do that because setting up a remote worker is really cheap, right? So you could just theoretically spin up a Windows VM, run a build there, and automatically scale it down so that you no longer need to use it after a while. Obviously, this comes with the implication that you need to be very familiar with RBE system. So yeah. Another footgun is we run into specifically some of the old rules that have not been platformization, like CC toolchain suite, still rely on some of the old flag, like minus CPU or host CPU, right? Or cross two tops, right? So if you run into these problems, consider setting CPU and host CPU specifically to make all of these works. Yeah, we run into this as well because these are predate the platformization of some of these rules. Another pro tips, enable, this is actually an experimental flag. I think there will be a talk after mine that is specifically about this, but experimental platform in output dir. What this is gonna do is that it's gonna change the naming convention under your Bazel out directory to include the target platform inside it. And the nice thing about this is that you can actually switch between local execution and remote execution seamlessly. So that, let's say if you're offline, you're on a flight, you don't have internet, you can still build locally, right? And then when you are off your flight, you can enable internet connection again and build remotely, all within the same Bazel JVM without like having to discard your entire Bazel out and then rewritten them again, which is expensive. Right? Yeah, and next talk, I think Fabian and Bazel team will talk a little bit more about this. Oh yeah, this is my favorite. Set UI action zone, because you are using RBE. You should be able to see more, right? So yes, this just increase the length of your terminal output, which personally I think it looks better. Our pro tips, use BuildBuddy. We have great UI, right? We display the, no, seriously, we do have a customer who find our UI very valuable, especially when you execute your action remotely. We provide the entire sandbox telemetry, so you know what's going in and out of your action, so that you can actually troubleshoot cache misses and missing input, slow execution, cache poisoning, that kind of thing. We even record everything that goes in and out of the remote cache, and then we display it back to you so that you could have greater telemetry into that. And yeah, all of the timing profile and stuff for remote execution. So yeah, what is the application of multi-platform builds today? Oh, my emoji is not rendering, right? Yeah, so multi-platform build keep developer really happy, right? I'm using it on a day-to-day basis. It's really fast. It helps me run the most complicated tasks without having to push to CI to run it for me, right? We have seen customers who are leveraging this to run a range of mobile device, like different Android SDK, iOS smart watches, smart TV, etc. Right? You could leverage Bazel to set up the most complex build environments out there, right? Another trend that we have seen is that there are a lot of companies with custom hardware, that is commodities, AI companies, right? Machine learning, or custom microcontroller with FPGA. Those could be defined at the platform, and Bazel could help you run that using remote execution. And that's about it. That's my talk. I will be taking some questions if there's any.
Hi, thanks for the talk. I was wondering how big the impact of like the network latency and bandwidth is, and for example, how would it work with a distributed team? Would you need multiple like builders distributed globally as well?
That's a really good question. So let's take it one at a time. What is the impact of network latency? I it depends, right? As most answer to this kind of question, it depends on your scenario, it depends on your situation. But built with other bytes, it's very minimal, right? Because you already load everything in your local setup. It's just a matter of you having to upload your input to the remote execution platform. And most of the time, it's going to be the delta, which is what you have already changed locally, right? So yeah, it's very minimal. For global distributed team, that's a very good question. It's challenging, right? We have heard from several different customers about using different remote cache system, trying to synchronize between them what is the right source of truth. To be honest, it's really depend on your constraint, right? It's like, if you look at remote cache and remote execution, that's from a scale, it's actually a database, right? So everything, every constraint that apply to a distributed database apply to the remote cache. And yeah, you're gonna have to scale it the same way, which is, cap theorem, that kind of thing. So yeah. For the camera, hello? Oh, question. Oh.
Hi. BuildBody is offering products for remote caching, remote execution, and the UI you just showed. I'm always wondering like how the adoption rate for those features of Bazel is. And for sure, you only have the experience with your own customers, but could you share maybe a bit like how many are using remote caching versus remote execution versus the build event protocol? Are those adopted at the same percentages, or are, for example, a lot of people using remote caching and remote execution is not that much used?
That's right. It really depends on your use case. We have, as I shown earlier, we have a wide range of different customer from the semiconductor industry, banking, right, even internet company, right? So depends on your use case. You see different usage pattern. Depends on what rule set you are using. You also see different usage pattern because some rule set actually don't do RBE at all, right? Some rule set like stuff related to Apple is very expensive to run RBE, right? Because you actually have to run it on Mac OS environment, which we actually manage, right? So it's hard to comment on that. In general, what I would recommend customers usually do is that try out the BES, the build event system first, because it's the easiest to onboard. You only send us the telemetry that Bazel emit, right? And that is usually very anonymized. We're especially comfortable for companies that are not used to sending source code to a remote system, and then remote cache, and then remote execution. But yeah, it really depends on different use cases. I think we have 3 more questions.
Thanks. You had on the definition of a platform, you had the CPU and OS as a target compatible with, but you also had target settings. I wonder if you have any advice on when to use which one to represent like what a particular target platform offers or has to offer.
Oh, this is really good. To be honest, we are still in the process of figuring this out, and we are discussing this internally just like a few days ago on a PR that you could go and read. But essentially, the idea that we want to move forward with is that we want to make sure that all of the properties that we're offering on our remote execution platform is implementation details. And then we want to encode those implementation details in exact properties. And then we're going to provide a set of config setting and config value. Config setting, constraint setting and constraint value. I keep getting those messed up, to higher level user. So for example, we run isolation sandbox on Firecracker, Podman, Docker, Bash Shell, etc. Those are implementation details, right? On a higher level, what user often interested in is, can my test, is the execution environment have a Docker daemon for me to run Docker Compose for my test? That's a big use case for our customer, which is running Docker Compose in a Firecracker micro VM. So we want to provide that as a higher level API. So we are still iterating through this design. It's not yet set, but I think that's the high level idea. Thank you.
Yeah, maybe it goes a bit in this direction. First of all, thank you for the talk. For the platforms, as you said, there was before this cross tool top, and basically like now we have the new way. But still, it's a little bit intermingled. Like you still have some very corner cases where you still have to rely on the old behavior. And basically also like in the last Bazel versions, there has been quite some cleanup where some places it was called host, but in reality it was the exec platform and stuff like that. And basically I wanted to ask you like, first, like how happy you are with the current status now. I think that quite a lot has been done. I think that there's one last step missing, but I wanted to know your opinion on that. Yeah, and then basically it's like, do you know if there are any plans, or I don't know if you have been talking to anyone from the Bazel team about finally getting rid of the all platforms topic?
Yeah, this is a really good question. In general, we are still going through the platformization ourselves, right? So the details has not been yet set. I'm pretty happy with it, right? I was able to get rid of all the cross-tool tops and host CPU and all those flags in favor of just registering a set of execution platform in the extra execution platform flags, right? And you could also register it in your workspace, but I find it less dynamic. We could talk on Slack about that. We don't have, we have yet to talk with the Bazel team about what their plan is, but in my general assessment, I think we need to do something about the CC toolchain on the side, because that's very difficult to set up in general. There's not a lot of good documentation about it. So a lot of things are just like magical incantation as far as I can tell. So yeah, if we could like work something out as a community to support that, because I'm pretty sure Bazel team has yet to set a target on that. So yeah, I think it needs to be community-driven effort. We have been, to be fair, we have been looking into Uber Zig CC toolchain. It does have some of the problem I described, which it used repository context.os to register itself, but I think that's fixable. And yeah, it's going to require some work. Yes, please.
In the interest of time, I think we
Yep.
should wrap up, and please find your
Yep.
speaker if you have other questions, and hopefully some of your questions will be answered in the next.
Yep, thank you.